Hi, this is Ilka Cassidy with Passive House Accelerator, and thanks for tuning in to the special bonus episode of the Passive House podcast recorded at Building Energy Boston 24. And a big thank you to New Energy Works for their support of the series. Good morning.
Good morning.
You just did a really amazing keynote. I'm here with Elaine Hoffman, Jennifer Johnson, and Patrick Murphy. So maybe Elaine, can you introduce yourself and tell us what you do?
Yeah. Elaine Hoffman, I'm Director of Sustainability at Goody Clancy. I'm an architect, and I work primarily on education-based projects in the campus environment specifically, which I think is relevant to the water topic.
Awesome. The session title was, What Will You Do When Your Project Floods? It's a little scary.
Right. I mean, and we're acknowledging the reality that flooding is so much more widespread now than it was, 10, 15, 20 years ago, and will become increasingly prevalent all over the region. I really loved in Jen's graphics section when she's showing the maps of development that we primarily worry, I think, too much about coastal or riverine flooding, but the whole region is subject to challenges. But as we were talking about a lot, it's not just, the title makes it sound as if it's all about flooding, but really we're interested in all aspects of the water cycle and how land development negatively impacts that because, and I think this is a line that you used during the presentation, but I'll repeat it because I think it's so wonderful. All of this damage happened one project at a time. And if we want to reverse it, we need to think about reversing it one project site at a time. So sometimes even if the project scales that we're working at seem too small to make an impact, that's not true. That's how the problem started. That's how we're going to undo it.
Awesome. And you explained this idea of the one water perspective or mindset. Patrick, can you explain? First of all, can you introduce yourself?
Yes, I'm Patrick Murphy. I'm the Director of Sustainable Design at Vanderweil Engineers. I'm an architectural engineer with an energy and mechanical systems focus and work collaboratively with architects and engineers to design sustainable projects.
So tell us about the one water perspective.
So as we were crafting the message for our keynote, we wanted to look holistically at the way that climate and water affect our projects and how the work that we do can respond to that. It's not just about flooding. It's not just about drought. It's not just about site water. It's also water within the building. And by taking this holistic, zoomed out approach, not just to our projects and the total water footprint of our projects, but also a zoomed out approach to the idea that our project site is our watershed, not just the property line. The holistic thinking can change the way that we think about and approach projects and make a better holistic water resilient solution.
Great. Jennifer, can you introduce yourself as well?
Sure. I'm Jennifer Johnson. I'm Executive Vice President at Niche Engineering, and I also serve as Director of our Resilience Planning and Design team.
Right. And what was your message?
So my message today was twofold. I think it's that we're at a critical moment in time now where we do have an understanding of how we got here, but maybe there's a little bit of uncertainty about how we move forward. So the two things I really wanted to have everyone take away were that we do have better information now to help serve our design teams and moving projects towards a more sustainable and resilient future, but that it can't just be the civil engineer or that mechanical and plumbing engineer or the architect. It's all hands on deck. And so all of us working together with that data, with innovation to push forward, that's how we're going to make change here.
Right. And you also showed very specific examples on how to go about that in projects. So Elaine, you were talking about measures to prepare for flooding incidents.
Yes. So one thing that I didn't mention was that after the Tropical Storm Irene flooding from 2011, FEMA redefined what the 500-year flood level was. They actually raised it while we were in early design. And so we were able to respond to that floodplain shift, which was great. Right. We're always happy when the regulations are adapting to the current reality that we're facing. So I think that site was unique amongst the projects that we shared because it did have a major preservation component. And I think that the intersection of preservation and water is a really tricky one because obviously you're not going to take all of these historic structures and build them, remove them and put them back on raised fill. So you have to find other measures and use kind of a constellation of different approaches to save what's most valuable, remove what can't be saved, and make sure that any additional development that happens is as low impact and as safe as possible. So that site combined all of those approaches, and it was, I think, really rewarding for the whole team that was involved in it, to see how successful it was last summer. Although I think, as I said, some of the measures like the dry flood proofing would only come into effect in the 500-year storm or something above the 100. So they have not yet been tested.
Great. And then Patrick, you were talking about reducing the water footprint of a project. I thought that was really interesting.
So within the typical medium or large scale project, the water that we think about a project using isn't just our toilets and our sinks. It's way beyond that. Projects that have kitchens or have irrigation, that's part of the water footprint. And the kind of hidden component of water use in a lot of larger projects is the cooling tower. That's the device that evaporates water and cools it down for our air conditioning systems within buildings. That process consumes a lot of water. In many projects, it's 40, 50+% of the total water footprint of a project. By looking holistically at the different ways that a building uses water and quantifying that, we can strategically reduce the water consumption through efficiency measures and also adapt to, say, the stormwater regulations that we're seeing adapted in Washington, D.C., in my example, which is a couple years ahead of us, or now in Cambridge, in Jen's example, that's now starting to lead the way in the Northeast. These regulations require us to be really conscious about the rainwater that does fall on our site, to minimize or eliminate the impact that rainwater has on the surrounding community and on the watershed. That's a resource for us. We can use that water within the buildings. We can use it to irrigate the plants, or we can use it for that cooling tower. But the challenge that we have sometimes is there's a seasonality to water use. It's not just about the annual total water use or water savings. Month to month, or even day to day, you'll have a stretch of a lot of rain, a stretch of drought. And to designing our projects to really react to that dichotomy, to go back and forth between drought and deluge, through reducing the water demand that we have and consciously using the water that falls on our site, is a holistic one water approach to making our projects more water resilient.
Well, and that's, with climate changing, it's probably only going to get more extreme, right?
Yeah. So early in our presentation, we were conscious about the approach of scary data at the beginning, but we really wanted to show that we already have solutions. This is more the last year or 2 years, especially in New England. Last year was well known for just being a very wet year, a lot of flooding in the interior in Vermont that caused a lot of damage, and even along the harbor here in Boston. But we already are forgetting that in 2022, it was a historic drought. The data is already showing that these last 2 years are a glimpse of our climate future. The 2023 sea level temperatures are a far outlier compared to all the previous years, and 2024 is off to an even worse start. Now, hopefully that settles back into more historic norms, but as the climate absorbs more CO2 emissions and heats up, 2023 is going to start looking like a normal year and not an outlier. So the last 2 years have really been an opportunity for us to see the challenge with our eyes, to see the effect that this climate has on our projects, to really wake us all up to what we need to do to solve it. And that's one of the great things about Elaine's case study, was that it was designed for a 100 or a 500-year flood. And within like almost instantly, it experienced a 100-year flood. A 100-year flood is no longer a 100-year flood. It's the norm now. 10-year flood now. And so, by, adapting to that climate future, planning for further out, that recognizing that the data that we had been using up until very recently was all historic looking, but that's no longer relevant. Things are changing too quickly. So designing for what that future will look like, what the building will experience over the next 20, 50, 100 years, that's the mindset that we need to have.
Yeah. And that was one of your points, Jennifer, data, correct?
Yeah, trying to reduce some of that uncertainty. We are getting more tools to advance that thinking. I think, whether you're at the local scale, maybe your municipality might have some additional flood data and might be doing some modeling or even monitoring to understand the conditions there. But even beyond that, at the state scale, New England states have really pushed forward with understanding the oceanic risks of climate change, whether it's sea level rise or storm surge or, related impacts from those. So we do have pretty detailed information now to help serve the basis of design and give us a much clearer understanding of what we should be thinking about. It's not today's condition. If it's a 50-year building or parking lot or athletic field, you've really got to think forward. And I think the other thing we talked about a lot as we were preparing this presentation is you might not have the budget to mitigate for the 2070 conditions now, but thinking about that now, bringing that to the table and understanding what it will take. We do still have time, but you want to make sure that you're planning for that and the site is adaptable to future conditions.
And I would take that as a takeaway for myself as my action item as a designer and Passive House consultant, and to really raise awareness of how important it is to integrate the water and really think about it in each project. So what would be your recommendation to designers and architects and, everyone who works on these projects?
So I would say the site is really the watershed. I think, it was so wonderful for us to, I think, frame the context of all of our projects within the watershed. That's not normally how people look at them. And if you only think about water within the boundaries of your site, you're really limiting your understanding of how it's functioning, right? Water is only within the boundaries of your site for a very short period, but what happens on your site can have major impacts beyond. And it's totally different if you're in the headwaters or if you're near an estuary. So it's just, there's not a single recommendation that I would make for all projects to prioritize, but I would say you have to look to where you are within your watershed, what the known impairments of the watershed are, to try and start to halt and or reverse the damage that's there.
Yeah, from the civil engineering or site mindset perspective, I've mentioned over and over again the importance of understanding the information available to you to inform your site design decisions. But beyond that, I think it's really important to have the right team in place to understand and interpret the data, and doing so very early in the project process. Sometimes that doesn't happen at the conception of a project, and you might miss an opportunity to really effectively integrate some of these design solutions. So understanding what data is available, what it's telling you, what it isn't able to tell you.
Can I tack on something to that, though?
Yeah.
Because it's something that you've said a lot, and I take it to heart, which is that, it's something, we were talking about the value of water and how water is very undervalued. And so oftentimes to do these stormwater and other major water measures and features, they often get value engineered out. But it's the most cost-effective time to do it is in the course of another project. So if it gets shelved during the development of a site, if later that site is subject to flooding and you have to come back and retroactively do it, that is far more expensive. And if we're talking about the trajectory of climate change, I hope we said this earlier in the presentation, I don't even remember now, the lifespan of the projects that are being developed now are a really critical period, right, in the period of climate change. And so when we miss an opportunity to do it on a site that's developed now, we're missing an opportunity potentially for decades or longer. So it's so important to act on active design work.
And our last takeaway for the audience was that, we all have the opportunity to create a ripple effect. That's both in terms of our projects, the work that we're doing, by agitating on our projects to take a one water approach, to think about water holistically, to incorporate, these strategies early on, to take a perspective that, the projects that we're designing now will have a ripple effect beyond their project boundaries on the watershed. But also, the NESI community is well known for its advocacy around energy and CO2 emissions and regulations associated with that. And that's very admirable for the longer term mitigation of climate change and its effects. But we're already seeing in the short and medium term that water is the way that we are seeing the climate change effect. So what we're advocating for is everyone to be the ripple effect beyond this room, to start advocating for improved stormwater regulations and a new mindset for approaching water resiliency on our projects, because 2023 was a glimpse of our climate future, and we know this is going to happen more often. It's now is our chance to course correct and to mitigate the damage that we've already done through our development over the last few generations.
Yeah, and energy and carbon emissions and water go hand in hand, of course, but also in a very direct way, as you presented on a project where you can use water to reduce energy consumption as well. So it's not just the big scale that we're looking at, but also on a small, very direct way to combine those elements of design. Can you just mention that really quick? Because I thought that was fascinating.
So in the case study that I had shown, we used a relatively innovative approach called a wastewater heat recovery system. Our stormwater and our sewer systems that, in larger cities, the water within them is a pretty steady temperature year round. That is maybe 50 to 70 degrees year round. We can use that as a source of heat for our buildings in the middle of the winter. It's warmer. That water is warmer than, the outside air is, with heat pumps. And so the strategy that we're deploying on a project in Washington, D.C. is to both absorb heat from the sewer system as a decarbonization strategy to avoid using fossil fuel boilers, but it also is a way to reject heat and put heat into the sewer rather than evaporating water in the cooling tower. So we're reducing that water consumption as well. So it had this kind of net benefit on both decarbonization and on cooling tower water consumption, which is the largest water consumer in a typical large project.
Thank you so much.